Hello everyone, welcome to Mayur Programming Club. Today we will be solving another daily Leetcode problem, and the problem's name is least number of unique integers after k removals. So given an array of integers and an integer k, find the least number of unique integers after removing exactly k elements. Okay, so this array ARR will be given to you, and along with that an integer k will also be given, and you have to find the least number of unique integers after removing exactly k elements. So let's have a look at the constraints. So here, if you before moving to the constraints, if you want to understand how the removals will be done, let's say only one element was allowed to remove, then you remove the element which is having the least frequency first. So 4 was only occurring once and 5 was occurring twice, so you removed 4. Okay, and you are only left with 5, and 5 is occurring twice, so frequency of the element that is remaining is not met, is not our concern. Only the element that is remaining is our concern. So 5 is the only unique element that is remaining, so we returned 1. Okay, so it is the least number of unique integers after removing exactly k elements. Okay, let's say if we have removed 5 instead of 4, then 2 unique elements would have been there. Okay, so if let's say instead of 4 you removed this 5, then you see that there are 2 unique elements remaining, and if let's say instead of 5 you remove 4, then only one unique element is remaining, which is 5. So that is how this problem is approaching. And now let's see the constraints. So the length of the array is of order 10 raised to power 5, and all the elements in the array will be ranging from 1 to 10 raised to power 9, and k will be either 0 or less than equal to 0 or greater than equal to length. So you can say that it will lie between 0 and length of the array, both inclusive. So let's see how we'll be solving this particular problem. What we can do is we can make a frequency map here. Okay, because we from example we were able to observe that we will be removing least frequency element first. Okay, removing least frequency elements first. So even if you take a bigger example, let's take this one. Okay, and k value was 3. Okay, now let's make the frequency map. So it will be number and its frequency. So number is 4. How many times this is occurring? Only once. Number is 3. It's occurring 3 times. Okay, so frequency is 3. So then comes 1. 1 is occurring 2 times. Then comes 2. 2 is occurring 1 time. Okay, this is the frequency map that we will be having, corresponding to the number frequency pair, and we are told to remove only the numbers with least frequency. So let's rearrange so that numbers with least frequency are on top. Okay, so 2 was occurring once, 4 was occurring once, then 1 was occurring twice, and 3 was occurring thrice. Okay, so if let's say there is a data structure or there is a bag kind of structure which always gives you least frequent elements. Okay, so you will be first removing 2, or you can remove either of them since both are having, you know, equal frequencies. Then you will be removing 4. Okay, so now you are left only with 1 and 3 since 1 was having least frequency, and we have already removed how many elements? 2 elements. So k value can now be equal to 1 only, so we have to remove only 1 element. So we will remove one occurrence of 1. Okay, so the frequency of 1 will be set to 1. So in total how many elements we remove? 3 elements, which were 2, 4, and then 1 occurrence of 1. Okay, and what will be remaining in the bag after this operation is completed? It will be 1 frequency of 1 and 3 frequencies of 3. So this is your number and this is your frequency. So you know, to implement a bag which is always giving us the least frequencies, we can use priority queue here. Okay, which is heap data structure. Okay, we'll be using min heap because minimum element will be at the top, so minimum in terms of frequency. Okay, so we will tweak the comparator of this priority queue a little bit so that always minimum frequency element is removed. Okay, so this is the logic of the problem. Okay, removing the least frequency elements first. So let's see how we'll be implementing it. So this is the implementation. First of all, we define a frequency map to get the frequencies of all the numbers that are there in the array. Okay, now once we are having the frequencies in this particular frequency map of each number, then we will define a priority queue or define a min heap which will keep minimum frequency elements at top. Okay, and then we will populate that minimum min heap or priority queue. Then once we are done with it, we are only left out to remove top k elements. Okay, top elements which are having minimum k elements which are having minimum frequency. Okay, so if let's say whatever the element is being written by your min heap, and that element is having a frequency, you know, greater than 2, in that case only you will be adding it again to the heap. Okay, so this is the case. Let's say if after deletion of one occurrence of this element, there are other occurrences remaining also. If after the deletion of one occurrence, or let's say instance of num, other instances are also remaining. Then we will add num again to the heap, or frequency heap to be specific. Okay, and this is we indicating, you know, removal of element, removal of one instance of num. Okay, removal of one instance of num. So once we are done with these operations, we will only be having the elements which are left after, you know, doing this operation, and it will be the minimum, you know, minimum unique numbers that will be remaining after removing exactly k elements. Okay, so we are keeping the elements which were having more frequency, so that the number of unique elements is reduced. Okay, so another way of saying stating this particular logic is keeping elements, or let's say saving elements of larger frequencies from deletion as much as possible, so that number of unique elements can be reduced. Okay, so here in this example also, if you have removed 5, then number of unique elements would have been 2, and if you remove 4 only, then you can see that we saved the element which was having larger frequency from deletion as much as possible, so that number of unique elements is reduced. Okay, so that is how we'll be solving this particular problem. If you are still having any doubts or any queries in general, then please ask them in the comment section. Thank you for watching. Have a great day ahead.